So Chapter 2 in Algebra is really going to focus on number types and properties of numbers, and just make sure that from our middle school years we're all on the same page with the expectations when it comes to the main operations like addition, subtraction, division, and multiplication, as well as the distributive property and square root. So that's really what Chapter 2 focuses on. It's a very quick chapter, and today we're going to focus on classifying numbers as whole, integer, rational, irrational, and or real numbers. We're going to focus on adding and subtracting positive and negative numbers, and then we'll wrap up this first chunk in Chapter 2. So to start, we're going to start with the classifications of numbers, and there are 5 main types of numbers that you need to know about. First, you need to know that the real numbers are the set of all rational and irrational numbers, and right now with your knowledge of math and numbers and algebra, the real numbers are really all of the numbers that you know. So all of the numbers that you currently know are considered real numbers. And you may be wondering why we have to call them real numbers. Aren't all numbers real? But there is another number system called the complex number system that you'll learn about in advanced algebra that are actually called the complex numbers. So real numbers are all the numbers you currently know, so things like 3.14 or 1/3, pi, 0, -6. All of the numbers you know are called real numbers. So from here, real numbers can actually be split up into 2 different types of numbers. So here I'm going to write real, and this splits into 2 types. And you have rational numbers and irrational numbers. So real numbers split into 2 categories. The rational numbers are anything that can be written as a fraction. So a and b, if it was a divided by b, are both integers, and b cannot be equal to 0 in that denominator. So there's a couple of things that could happen. First, you could have a fraction. A fraction is considered a rational number. So something, for example, like 1/3. The second option is that you may have a decimal that stops. So something like 0.333. That decimal stops, and because it stops, we could write that as 333 thousandths. So we can write that as 333 over 1,000, and as a result, it can be written as a fraction. The second thing that we can have is we can have a decimal that repeats. That's also a rational number, because something like 0.333 repeating can actually be turned into a fraction of 1/3. So any decimal that repeats is also a rational number. And then from here you have the normal numbers like the integers and the whole numbers like -5 or 0 or 4. So those are all classified as real numbers. So real numbers are any number that you could, if you tried, write into a fraction, and you can see some of the examples below. Now, an irrational number is something that cannot be written as a fraction. So there's no way to turn it into a decimal because there's no repeating decimals, so that's something to keep in mind here. There's no repeating decimal. And the decimal does not stop. So it keeps going and going and going and going and going, but there's no repeating to it. So this means that a number like pi, 3.1415926, and it keeps going with no pattern, pi is an irrational number. Something also like 7.28973, and it just keeps going randomly. That's also an irrational number. Something like the square root of 12, where if you were to actually calculate that out on your calculator, it's not a nice number. It goes in a crazy pattern forever. Those are all examples of irrational numbers. So remember that you can take a real number and you can split it into 2 types. It will either be rational or it will be irrational. Now, to get even a little bit more specific, we have special types of rational numbers. So these are both rational types, but it's basically being more specific about the rational numbers. So the first type of rational number that you could have is called a whole number. So you have, those are your counting numbers, like 0, 1, 2, 3, 4. You can see them all right here. And the whole numbers are always going to be positive. There will be no negatives there. They're the numbers that you would use to count items in front of you. Now, an integer, on the other hand, is essentially all of the positive and negative whole numbers. So you take all of those whole numbers and you turn them into the positive versions and the negative versions. So something to note here is that integers have no decimals. And also the whole numbers, because they're counting numbers, have no decimals. So these are two types of very, very specific rational numbers. And you'll need to be able to classify or decide if something is an integer, if something is rational, things like that. Now the image in front of you is meant to help you kind of classify your thoughts when you're looking at whether a number is real, rational, irrational, whole, or integer. So this graphic organizer kind of helps you to organize all of these definitions I just gave you. First, that whole big box, all of these numbers in this big box represent real numbers. So all of the numbers that are in this box are real. So that box represents all of the real numbers that you have. So if you want to write it as like this, like all of these are real numbers in this box, that would be great. Then from there, remember, real numbers split into two types of numbers. You have irrational numbers and rational numbers. So this side on the blue, all of this blue chunk, those represent your rational numbers. And this pink chunk represents your irrational numbers. So we've split real numbers into its two types, rational and irrational. Then from here, rational starts to get a little more specific and a little more specific. So inside of rational numbers, we also have an area, which is that green circle, of numbers that contain no decimals. So the green circle is all of the numbers that contain no decimals, and those are your integers. So those are things like -3, 4, -5, 10, any number that doesn't have a decimal, and it can be positive or negative. And then from here, the integers get even more specific, and you can go into the group of integers and pull out just the whole numbers, those counting numbers. And the whole numbers are right inside of there. So whole numbers, remember, are like 0, 1, 2, 3. They're all of the positive integers. So we can kind of work our way in and see how these numbers are all related. We start with all reals, then we split into irrational and irrational, and then rational gets more specific to integers with no decimals, and then integers gets more specific to whole numbers, which contain only positive integers. So from here, we're going to practice categorizing our numbers. And remember that a number could fall into multiple categories. For example, a number could be real and rational. So we have to be careful as we go through these. They won't necessarily only have one word or classification underneath them. So to start, we look in front of us and we see all numbers that we are familiar with. And we know that all the numbers we are familiar with are real numbers. So what I'd like you to do is write the word real under every single one of these numbers, because they are all real numbers, every single one of them. They all classify as real. Now from here, we need to decide from those real numbers, since they're all real, is it rational or irrational? And remember, rational numbers can be written as a fraction. So -4 I know could be written as a fraction as -4/1. So I know that -4 is in fact a rational number. 1/3 is already written as a fraction, so I know that that would be a rational number. I know that 0 could be written as about 0/4. That would give us 0. 0 can be written as a fraction, so 0 is also rational. I know that the square root of 16 is really equal to 4, which can then be written as a fraction as 4/1. So I know that 16 is also rational. I also notice that this decimal here stops, so even though there's a lot of 3's, it's a stopping decimal, which means I could write it as a fraction if I wanted to, and as a result, this is also rational. However, to end, let's look at the square root of 12, because as you can see, I kind of put it on the screen. If you were to plug that into your calculator, do the square root of 12, it would end up as 3 point and then have a bunch of decimals after it that don't repeat and don't stop. And as a result, the square root of 12 is actually an irrational number. Now from here, we still have to decide which numbers are integers and which numbers are whole counting numbers, or which ones have both. So if we look at -4, we can see that -4 is an integer because it's a number with no decimal point and it's positive or negative. So I go here and say, okay, this is an integer. However, because -4 is negative, It is not a whole number, so I'm not going to label that as a whole number because a whole number has to be positive. Then if I move to 1/3, I notice that 1/3 would be a decimal. It would be 0.333 repeating. So that is not an integer and it is not a whole number, so I've classified that fully. Then I look at 0. 0 is a number that does not contain any decimals after the first number, so I know that this is in fact an integer. And then from there, because it is also one of the counting numbers, it's also a whole number. And then if I jump down to 4, the same thing with 4. It does not contain any sort of decimal, and as a result, this would be an integer. And because it's one of our positive counting numbers, it's also a whole number. Then from here, 0.33 is also a rational number. However, because it contains a decimal point, it is not an integer, and as a result, also not a whole number. And then 12, because it's irrational, we already know that that's not an integer. So as you work through classifying these numbers, be very careful. Make sure you know the definitions of real, rational, integer, irrational, and whole so that you know which categories each number falls into, and that you recognize that it may fall into 2, 3, maybe even 4 different categories. Alright, so now we're just going to spend some time quickly refreshing your memory on how we add real numbers. I have a number line at the top to kind of help us out. So the first problem is -4 plus 2. So if we were to make a number line there for -4 plus 2, we could kind of put some numbers on here and say that we're currently at -4 and we're going to move in the positive direction 2. That's really what addition is. So -4 plus 2 would give us -2. Now from here I can do the same thing with 3 plus -5. I put 3 on my number line, and I know that I'm going to have to move in the negative direction 5. So if I'm at 3, I move in the negative direction 1, 2, 3, 4, 5, and I end up at -2. And then from here, the last one that we're looking at, again, addition with two negative numbers. We have -2, and we know we're moving in the negative direction 3. So I'm here, okay, -2, and I'm moving in the negative direction 1, 2, 3, and I end up at -5. So that's just a quick reminder on how we add with positive and negative numbers. Alright, so now that we've reviewed addition, we need to review the basic rules of subtraction. So something to note about subtraction that makes it much, much easier is that subtraction is simply adding the opposite of B to A. So we can turn every single subtraction problem into an addition problem. So what I mean by this is right here you see 3 minus 2. Really what subtraction is adding the opposite of 2 to 3. So really this can be rewritten as 3 plus a -2. We're adding the opposite of 2. That's what subtraction is telling us. So this subtraction problem can be rewritten as 3 plus a -2, which would then equal 1. And then it's the same thing for 5 minus a -7. We are adding the opposite of -7 to 5. So we can switch this into 5 plus, because the opposite of -7 is a +7. It will be plus a +7, but that looks kind of silly with two plus signs, so it can simply be written as 5 plus 7, which is 12. So my trick with the subtracting a negative is if you see here you have these two pieces, they look like the up and down and the sideways piece of a plus sign, and those two come together to turn it into addition. So that's kind of my little trick with adding negative numbers. So if you don't like subtraction, always change it into adding the opposite. I know a lot of you in middle school called this the add-op rule, and you can use that here as well. So next, while adding and subtracting with integers is all fine and dandy, we also have to be able to add and subtract with fractions. So you can see here this particular slide focuses on fractions, and you should all know from middle school that if you're going to add or subtract with a fraction, they must have what are called common denominators. So you're going to have to convert them into having common denominators if they don't. So here we see in this first problem we have 1/2 plus a negative 2/5. So the first thing we need to do is find a common denominator that we can convert these both into. The easiest thing for me to do is I always look and I see a 2 and I see a 5. And I know 2 times 5 is 10. So I know I can convert them both into tenths. So I can change 1/2 into something over 10 that's equivalent, and negative 2/5 into something over 10 that is equivalent. So what I think of here is I know that in order for the 2 to become a 10 in the bottom, I would have to multiply it by 5. And as a result, I'd have to do that to the same thing as my numerator. So 1/2 written in tenths is really 5/10. Then from here, same kind of trick. I need the 5 to be a 10. So I multiply it both the top and the bottom of the fraction by 2. And as a result, this becomes negative 4 over 10. And I know if I were to reduce those fractions, they would go down to 1/2 and negative 2/5. But I want the common denominators to add them together. Now from here, I add the numerators and leave the denominator alone because I'm combining those into one fraction. So I have 5/10 plus a negative 4/10, which leaves me with a positive 1/10. Then from here, the same thing applies to problem number 2. I need to find a common denominator. So again, I look at my two denominators and I see 3 and 4. I multiply them together to get 12. And so I know that my common denominator goal is to have denominator of 12 for both. So in order to convert that first one to have the 3 become a 12, I would need to multiply both the top and the bottom by 4. So that becomes 4 over 12 minus, okay, I need to have a 12 in the bottom here, so I must multiply by 3 in both the top and the bottom. So it's minus a negative 9 over 12. I also know from the previous slide that if I'm subtracting a negative, that changes into addition. So this 4/12 really becomes plus 9 over 12. So I'm trying to figure out how many 12ths I have. I have 4 plus 9, which gives me 13/12. So you should be familiar with fractions and converting them into having common denominators so that you can add or subtract them. This is kind of your reference slide for if you forgot how to convert fractions into having common denominators. Make sure you review that concept because there will be fractions on your quizzes and on your test. Alright, so on this final slide, we're going to use the substitution property we talked about last chapter and combine it with the addition and subtraction rules we just kind of talked about. So one thing I would like you to get in the habit of is be very, very careful as you substitute, especially with the negative numbers, like here when x is negative 7. Get in the habit of using parentheses to substitute. That really will save you down the road, and it will prevent you from making any sign errors. So for example, in this first problem, we need to substitute in 3 for y. So I have 3 minus, and x is a negative 7. So notice how by using parentheses I can make sure that I'm not missing that x is a negative 7. Then from here I notice that I'm subtracting a negative, so these two together are going to form a plus sign. So I have 3 plus 7, which ultimately gives me 10. And then if we repeat this same idea over in number 2, we can see that x is negative 7 plus y is 3, and then we have a subtraction of 4. If we start by adding and subtracting from left to right like we know our order of operations work, negative 7 plus 3 leaves us with negative 4, then minus 4 more, which ultimately gets us to negative 8. So nothing too tricky, just be really careful with those negative numbers. I would make sure you always substitute with parentheses just to make sure that you're safe and that you're not going to make any mistakes. So at this point you should be done with your note sheet and have it completely filled in, and we'll see you in class tomorrow so that you can practice with your peers.